Hey there, math peeps. This is Mrs. Marshall, here to teach you about inverse trig functions and inverse trig compositions. So to begin, the trig functions, sine, cosine, tangent, cosecant, secant, and cotangent all have infinitely many solutions, which just means there are multiple angles on the unit circle whose, for example, sine is square root of 3 over 2. And we have reviewed this in the class. All you have to do is just go around the unit circle over and over and over, land at the same spot. And the amount of times you went around, that's your angle. But the inverse functions, which we're only going to talk about 3 of them, and we're going to use those 3 to essentially find the answers for the other 3. They have restricted solutions, which means they do not have infinitely many solutions. There are just a certain few. So we're going to use the graphs below so we can figure out what this even means. Let's begin with the cosine function. Cosine is a little bit different from sine and tangent, so I want to start with cosine. So our cosine function, we're going to think about just this part of the graph. And the reason why is because when you're finding inverses of functions, you're just flipping the y and the x. Or on the graph, you are flipping the graph over the line y equals x. So we're going to draw the line y equals x. It looks something like that. And now we're going to do the reflection. And our reflection, let's try to do that. Looks something like this. And it goes on and on and on forever. But see, the problem of this going on and on forever for the highlighted graph is that it is not a function. Why? Because it does not pass the vertical line test. And so that we want the equation of the inverse to be a function, we have to restrict the graph. That's it. You just got to restrict the graph. So our graph restriction is this picture to the right. And we technically could make this go on and on and on forever. But again, it would no longer be a function. So our graph restrictions will be as follows. The domain is -1 to 1. And the range is 0 to pi. The notation, before I forget that, is y equals cosine with a little -1 power of x. You always put the -1 in front of the x. Or you can write arc cosine. So these two notations mean the exact same thing, the inverse of the cosine function. On the unit circle, your domain and your range. Well, the unit circle is 1 to -1 anyway, so the range is essentially the part that we need to know. That's 0, and this side is pi. And they are closed circles because you can equal 0 and pi. And it goes in a continuous motion to the left. So it's all those values on the top half of your unit circle. So let's fill in the unit circle. So we have 90 degrees here. 60, 45, 30, 0, 0, 120, 135, 150, 180. And then filling in those radians. 2, 3, 4, 6. This is 1 less, so 2 pi over 3. 3 pi over 4. 5 pi over 6. And pi. Next, I want to fill in the coordinates. So our coordinates are 0, 1. And then I do the counting trick. 0, 1, 2, 3, 1. And then go backwards. 0, 1, 2, 3, 1. And then we fill in the left, which is -1/2, negative square root of 2 over 2, and negative square root of 3 over 2, and -1, 0. Last thing, I want to definitely fill in those tangents so that they are on my circle and I just have them. This one is sine over cosine, so 1 over 0, that's undefined. This one I like to think of it as O over A. So square root of 3 over 1 is square root of 3. Square root of 2 over 2 is 1. And 1 over square root of 3, when we rationalize the denominator, is square root of 3 over 3. And 0 over 1 is 0. And then my left quadrant is exactly the same, except for we put a negative on it. Negative square root of 3, negative 1. Negative square root of 3 over 3. And negative 0. What? And 0. All right, let's do the sine inverse function. Switch my colors. Okay, so for my sine inverse function, we are going to use this portion of the graph, boop, right here. And that ends up being, when we reflect over the line, y equals x. All right there. Let's scoot it over to the 0 right quick, okay? Now let's do the picture, and it looks something like this. Something like that. Let's make it a little thinner. Boom, boom. All right, that looks a little bit better. But essentially what happens is it goes on and on and on forever, up and then down, and that is not a function. So it fails the vertical line test yet again. So we have to restrict that graph. And our restriction, I don't know what I was about to say. The restriction looks like this. Again, I could keep going on and on and on forever, but then it wouldn't be a function. So our restriction this time, domain is -1 to 1, which still makes sense because of the unit circle. And our range is negative pi over 2 and pi over 2. Remember, we got to do the notation. So arc sine x is the notation, or y equals sine inverse, and you just read that as inverse, but you put a -1, x, which just means the inverse of the sine function. On the unit circle, your pi over 2 is up at the top. You know where pi over 2 is. That's that 90 degrees. And you're going in the correct direction on the unit circle. But then to get to negative pi over 2, that's technically in the 3 pi over 2 spot. But it has to be within the range. So 3 pi over 2 is not allowed because that goes past your range. And you cannot do that. So our answer instead is negative pi over 2. You got to be careful with these. Got to be careful. Let's go ahead and fill in this unit circle one more time. We have 90 degrees, 60, 45, 30, 0, 0. But then remember, it's those values in the first quadrant turned negative. Negative 30, negative 45, negative 60, negative 90. And then we do our radians. Pi over 2, 3, 4, 6. And these turn negative as well. Negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Your coordinates, however, they're exactly the same as they would be on the regular unit circle. So 0, 1, 2, 3, 1, 0, 1, 2, 3, 1. Already got that. And now we just do the reflection. And this is square root of 3 over 2, negative 1/2, negative square root of 2 over 2, and negative square root of 3 over 2. All right, let's do those tangents. Last part. Undefined, square root of 3, they're just literally the same from the one above, 0, and then these are the same but just turned opposite or negative. Negative 1, negative square root of 3, and this is undefined. All right, last one is our tangent inverse function. And our tangent inverse function, the part that we are going to use is this first graph. Why? Because when we reflect it, we don't want to have a whole bunch of graphs going horizontally and then it definitely fails the vertical line test. No. So all we need is that first graph, and then we're going to reflect it across the line, y equals x again. All right, yes, beautiful. And that one will look something like this. And that produces the graph to the right. But the thing that you must know is that this goes on and on and on forever, to the left and to the right. But it gets close to those two asymptotes, negative pi over 2 and pi over 2, which is going to affect our domain and range. Domain, not a bracket this time. It's a parenthesis because it's negative infinity to infinity. And our range is bottom to top. But since they're asymptotes, they are also parentheses. Negative pi over 2 to pi over 2. Let's go ahead and do that notation one last time. Y equals tangent inverse of x with that little -1 power, or that arc tangent x, which is the exact same thing, and our range. Both of them are open circles because they cannot technically equal pi over 2 and negative pi over 2. But it's very similar to the sine graph in terms of the way the graph looks, also in terms of what portion of the unit circle you use. All right, so let's do some examples. All right, inverse trig examples. You are going to think, what angle is the trig function that value? Anytime you see that little -1 power or the arc, you want to think, what angle, what angle, what angle, what angle, what angle. So again, that's whenever you see arc or whenever you see to the little -1 power. That is what you are going to think. So number 1, I see that -1 power. So what angle, and I'm going to abbreviate angle with the symbol, is sine 1/2. So fill in a little coordinate, and 1/2 is the y value. So the possible x values are square root of 3 over 2 and negative square root of 3 over 2. But it must be within the range. So I think about my range. Positive can be is there, possible. Yep, yay. Negative positive is over here, and that's not possible. So we cross out the negative, and the angle 1, 2, 3 is pi over 6. Ta-da! And we're done. Next, we see arc. So we got to think, what angle is cosine negative square root of 3 over 2? So set up my coordinate. My possible angles are positive 1/2 and negative 1/2, but choose the one that's within the range. So negative positive, yay, negative negative, nope. So we scribble this one out. And 1, 2, 3, that's here. And that is 5 pi over 6. And our last one, arc tangent. We see arc again. So you think, what angle is tangent negative square root of 3? Well, in this case, I put a 1 underneath so that I can write my actual coordinate. So that's negative square root of 3 over 2 as my sine, and then my cosine is 1/2. Or we could have negative and then positive. So I'm going to put my signs accordingly and make sure I choose the one that's within my range. Positive, negative, yep. Negative, positive though, nope. So I scribble out those bottom symbols. And 1, 2, 3, starting from the top. So that's 3, 2, 1 going to the bottom. So 1 will be here. And that is, got to be within the range. Negative pi over 3, not 5 pi over 3. And that's your answer. All right. Next section. You're just going to plug these into the calculator, and you just got to make sure your mode is whatever it tells you to express your answer in. So for the first one, we need to make sure it's in degree mode. But for the second one, it needs to be in radian mode. And you're literally going to just type it into the calculator. How do you get it though? You press second, and then whatever the trig function is, second tangent, for this one, and the answer is negative 32.14 degrees. Just make sure you round correctly and make sure you put the degree symbol when it's degrees. But for this next one, cosecant inverse, there is no cosecant on the calculator. So we have to change that to sine. But you can't just take the sine of that number and that's the same as the cosecant. We have to do the reciprocal because since sine and cosecant are reciprocals of each other. And the reciprocal of 1.2618 is 1 over 1 point. Let's make that a 2618. And our answer is, change it to radian mode, 0.9149. It works this way every single time. When you have cotangent inverse, you're just going to do the tangent and put 1 over the number. If it's secant inverse, you're going to do the cosine and put 1 over the number because you have to create reciprocals. And those are the 2 examples. Our last example from this section is find the exact solution. Notice it does not already start out with inverse, so in this particular case for number 6, all angles apply when problem doesn't start with inverse. Okay, so, but you have to think of it in the same way though, in terms of how you solve it. So we want to get theta by itself, just like a regular algebraic expression or equation. Get the variable by itself. The way we do that to get rid of sine is you take the inverse of it. Just like when you're multiplying, you do the inverse of multiplication and you do divide. Well, the inverse of sine is just sine inverse. This goes away, and theta equals sine inverse of negative square root of 3 over 2. And now you have to think, what angle is the sine negative square root of 3 over 2? But in this case, all angles apply. All angles apply. And so the angles where it's negative square root of 3 over 2 is where you have a positive or negative 1/2. And where that ends up being on the circle, I always have to see the circle for me to get the answers to these, is, okay, let's do a full circle. And we want positive 1, but negative square root of 3 over 2. Okay, get that off. There we go. Positive 1, negative square root of 3 over 2. And negative 1, negative square root of 3 over 2. And so if I wanted the answer in radians, we'd know how to do that. That's very easy. That's in the third quadrant, so that's 1 more, 4 pi over 3. And that one's in the fourth quadrant, 2 times the denominator minus 1, so that's 5 pi over 3. But what if I wanted it in degrees? I just want to make sure that we don't forget degrees since we've been using radians a whole lot. So 4 pi over 3, I just think of, well, the number in the middle is 270. Also, with radians, I know that that pi over 3 was my reference angle, so that's how I knew everything had a denominator of 3. But for my degrees, this is 270. And I know I'm going to plus or minus 15 degrees. And so 270 plus is 285 and minus is 255. And those are my 2 answers. Woo -woo. Now let's do number 2. Same situation. We got to get x by itself. So we want to divide both sides by 2. That goes away. And so this is cosine inverse of x equals square root of 2 over 2. Well, we want to get rid of that cosine inverse. Well, you're just doing the cosine because the inverse of cosine inverse is cosine. Those go away. So x equals cosine of square root of 2 over 2. But be careful with this one. This is saying that square root of 2 is an angle. So be very careful. That doesn't exist. Like, that's not on our actual unit circle. So if we want the exact answer, this is the exact answer. But if I wanted you to actually solve it, you just put it in the calculator in radian mode. 0.7602 would be your answer. And again, you put it in the calculator in radians. All right. Let's do the next part. Compositions. When solving inverse trig compositions, you are going to solve from inside to outside. Now, what in the world does that mean? You're just going to start from the inside section and then figure out the answer, and then do the outside section and figure out that answer. So, for example, number 8, we see that inverse. What angle is tangent square root of 3? So, let's set it up. We want square root of 3 over 2. And this is going to be positive or negative 1/2. But remember, you must be within your range. And so negative doesn't even work. So it has to be positive, positive. And that is up here. And so that angle is pi over 3. And now we want to do the sine. Do the outside. What is the sine of pi over 3? Oh, it's that coordinate that we literally have already written. Square root of 3 over 2. And that's our answer. Inverse of sine of 7 pi over 4. So sine of 7 pi over 4 is, well, I got to do my unit circle. 7 pi over 4 is definitely in the 4th quadrant. And it's, boop, right there. So we know that's negative square root of 2 over 2. And then sine inverse, what angle? Oh, we don't have to rewrite it this time. It's exactly what I want. What angle is the sine? And so negative square root of 2 over 2. And then square root of 2 over 2. It has to be within the range, though. And that's definitely going to be positive. Negative. Oh, it's the same value. Oh, but it's got to be within the range. So it's negative pi over 4. All right, and our last section is solving these with right triangles. Why? Because the values are not on the unit circle. So we have to use a right triangle to figure out the answer. First things first for this first one, we got this weird looking number. We want to undo the rational denominator. Rational denominator. The way you undo it is you times by square root of 21. That's how you got the answer to begin with. So times to get rid of it. And that is going to be 2 times 21 on top, all over 21 square root of 21. Those cancel. And so that's going to be 2 over square root of 21 all over again. And since this is cotangent, cotangent is opposite of TOA. So it's A over O. And then we do our triangle. Okay. So my adjacent is 2. My opposite is square root of 21. I'm going to move this up a little bit. And let's solve it. Square root of 21 squared plus 2 squared equals c squared. Well, that's 21 plus 4 equals c squared. And so, oh, that's just going to be 25. So 5 equals c. And now let's solve exactly what we wanted to solve. We wanted to solve and find the secant at the end of the day. So the secant of theta equals, well, secant is opposite of cosine. Cosine A over H, so H over A. I always have to think of the reciprocal function first, always. And H over A is 5 over 2. And that's our final answer. Last one. Same thing. There's nothing to undo. We have single digits on top and bottom. So we just figure out what that is. Tangent is O over A. And now we do a triangle. The opposite is x. Adjacent is 2. X squared plus 2 squared equals c squared. Sometimes you have a c value and you have to solve it by subtracting. It just so happened both of these ended up being add examples. And this is x squared plus 4 equals c squared. And when we take the square root, oh, it literally just adds the square root to the other side. You cannot solve it separately. You have to leave it as one whole expression. Square root of x squared plus 4. And then we essentially want to figure out what the sine of theta was to begin with. And so we have so over h. Our opposite is x over our hypotenuse, which is square root of x squared plus 4. But don't forget to rationalize the denominator. So that's x square root of x squared plus 4 over x squared plus 4. And this concludes our video, guys. Marshall out.